Good morning, all of you. In today's session, we are going to start with the 10th standard chemistry and physics, unit number 9, electrical current, series number 4 is going to be discussed. Earlier, we completed what is the origin of current and how the bulb glow is possible. By doing activity, we performed all the sequential steps which are required for the illumination of bulb. So that activity performed and even what is meant by current and what is the derivation of drift velocity equation and how it will be quantitatively determined. Those topics have been completed. In addition to all these, unit number 1 to 8, entire detailed explanation available on the channel called World of Competitive Chemistry. Now we entered into series number 4, where we are going to discuss about what is meant by potential difference and how it will be used for the origination of electricity in the battery, and how EMF will be generated. That topics will be discussed in the subsequent sessions. Let us enter into our today's session series number 4, where potential difference is exclusively going to be discussed. Potential difference. When the ends of conducting wire are connected to the terminals of battery, electrical field is set up throughout the conductor. This field exerts a force on the charge, right? So here we can see we already performed this activity where battery was taken and connected with the connected two terminals with the conducting material. Let us assume it will be the copper wire. Now it will be connected to the bulb, where illumination of bulb is possible due to the formation of electrical circuit. It is in the closed web, so that here electrical circuit was made and illumination of bulb is possible. Electrical force between two electrons is the same as the electric force between the two protons when they are placed at the same distance. Electric force is nothing but when two electrons are placed in the under the electrical force between the two protons, they are placed in the same distance. Electrical charge of each and every electron is given by 1 by 1.6 into 10 to the power minus 19. This will be the constant parameter which assigned for each and every electron. So this is for the electrical force. Let Fe is taken as the force exerted by the electrical field. The extent of force exerted by the electrical field is denoted with Fe, and field on the free charge Q. Here, charge of the electron is denoted with the parameter called Q. The free charges accelerated in the direction of electrical field. If the free charges are electrons, then the direction of electrical force on them is opposite to the direction of electrical field. Free charges or electrons. These electrons, direction of electric force on them is opposite to the direction of electric field. So how they're experiencing the force, that will be exactly opposite to the electric field which is present in the given circuit. It means that electrical field does some work to move free charges in the specified direction, right? So here, when we are taking the electrons, so these electrons, in order to move these electrons, what we have to do? Some extent of work to be done by the electrical field. So in which direction, in what way they are moving in the same direction, in the same specified direction, electric field should expend their some extent of work. So that is the kind of system where electric field used to exert some work in order to move the charges in the specified direction. Now, can you find the work done by the electrical force? So is it possible to monitor? Is it possible to observe how the work done by the electric field? So in order to get that, we have a diagrammic representation. Direction of electric field is in this manner. Electrons are moving, electric field is moving in forward direction, right? Let the electric force made the charges move through the distance L. The distance traveling by this electric charge will be denoted as L, and in between the points of A and B. So here the points of A and B were taken in between, and the distance traveled by the electric field was taken as L, as shown in the figure 5. We know that the work is the product of force and distance. So how extent the work done, denoted with W, is the product of force. Force is nothing but electrical force here. And the distance denoted with L, how long this electric field is going to be traveled, that is taken as L. So here work done by the electric field is equal to electric field force into length of region where the electric field is going to be traveled. This product is known as the work. Hence, work done by the electric force the free charge Q is given by the empirical formula W is equal to Fe into L, right? So in this manner, we can measure how extent work done by the electric field by using this formula. Now, what is the work done by the electric force and the unit charge? Here, can you get the right answer for this one? So let us go to solve this problem. Work done by the electric field, unit charge is given by W by Q. Work done is given by specified electric charge is taken as W by Q. This is given by Fe into L by Q, because both the sides we are dividing with the charge Q, because if both the sides of Q was added, there is nothing will be changed. That's the reason why. So just now we got the equation W is equal to Fe into L. Now both the sides of Q will be divided. W by Q is equal to Fe L by Q. Work done by the electric force on the unit positive charge to move it through the distance L from the point A to B is called a potential difference. Here is the definition for the potential difference. What is the potential difference? Work done by the electric force. Work done by the electric force, that is denoted with W. And unit positive charge, that is denoted with Q. To move it through the distance L. So distance is denoted with L from the point A to B. So this distance covered in between the two integer points, that is A and B. So this is called as potential difference. This is called as potential difference. And the potential difference is denoted with the symbol V. V denotes volt. The potential difference between 2 points separated by the distance L in a conducting wire is given by V, means a potential difference is equal to W by Q. It is the ratio of work done by the electric field and the unit positive charge is equal to electrical force into length traveled by the electric force by the unit charge where we are applying. So this is the formula in order to calculate the potential difference, right? And move on to definition followed by derivation for this one. Let us define this potential difference first. The electrical field is by the definition force per a unit charge. So that multiplying the field times the plate separation gives the work per unit charge, which by the definition change in the voltage. Here, potential difference is also alternatively defined as a change in the voltage. Change in the potential is also denoted as change in the voltage. That is given by the formula called a ratio of work done by the electrical field to on the unit positive charge. So this W by Q is simply denoted as a potential difference, right? So here is the definition for this one, and let us derive this equation. W is equal to F into R. W is equal to F into R, since F is the force is equal to Q into E. Now E is replaced with Q into V by R, where E is equal to V by R. We are going to substitute the known parameters here. So based on this, W is equal to Q into VR by R, right? So here we are specifically mentioned in this manner. So VR by R. QV, rearranging this equation completely, what happens? V is equal to, so here what happens? W is equal to QV. W is equal to QV. W is the work done, Q is the charge, and V denotes what this energy is transformed into this electrical potential, volts, right? So now it is required to calculate this electrical potential, that V is equal to W by Q, right? Where V denotes a work done and Q is the charge and F is the Coulombic forces, E is the electrical field what we are applying, R is the distance traveled, and V is the electrical potential. All the parameters what we used in this equation will be mentioned here. W is the work done and F is the Coulombic forces, R is the distance, and Q is the charge, F denotes what? Coulombic forces, and V is the electrical potential. Finally, electrical potential is equal to work done by the charge. So here, note that 1 ampere, assuming the simplest case scenario, and I have not written any of these assumptions, right? So this is the finalized equation in order to measure this potential difference. And what is the work done by the electric force and the unit charge? So on the unit charge, how extent work done is V is equal to W by Q. That is given by F E into L by Q. And it is defined as, so here potential difference is given as the ratio of work done with the unit charge. And it is derived like this, V is equal to W by Q. So this is the simplest form of representation for this potential difference. Now, this potential difference is also known as voltage because it is denoted with V. V denotes a voltage. In SI units, potential difference measured in the parameters called volts. It is denoted with V. Volts nothing but V. Volta is the scientist who first invented about this electromotive force and potential difference, and all these experiments were done by the scientist Volta, so that in this regard the name volt was given. 1 volt is equal to 1 joule per 1 coulomb. 1 volt exactly is equal to 1 joule per 1 coulomb. So here 1 volt is equal to 1 joule per coulomb. So this is a kind of representation, scientific representation between the different units in order to convert one unit into another. Volts can be converted into joules per coulomb in this manner. Now, another question was posed for you. This is the time for the question. What is the direction of electrical current in terms of potential difference? So with respect to potential difference, what will be the direction of electrical current flow? I collected this answer from Brainly. Thank you very much for your valuable information in this regard. And in order to get this one, electrons move from higher potential to lower potential. Always higher to lower potential is possible. The water always try to flow from higher amount to lower amount. In the similar manner here also, potential is moving from higher to lower region in order to maintain the equilibrium, right? That's the reason why here always the tendency when this electrical wire is connected with the battery, higher potential to lower potential movement of current is possible. And when it is present in the circuit, and it moves from the negative terminal to the positive. Negative terminal denotes what? High electron density. Positive terminal denotes what? Low electron density. And that is graphically mentioned in this diagram form, where electron flow is possible from high density to low density in order to make the equilibrium, right? So this is about the direction of electrical current in terms of potential difference. Now, another question is there. Do positive charges move in a conductor? Can you give an example for this one? I collected this answer from Doubtnet. Thank you very much for your valuable information. In solid conducting material, positive ions do not move. Why? Let us take a copper wire, because it is the simplest example familiar for us in our daily life. We are using in a continuous manner. So we are taking a copper wire. Through that, electricity is going to be passed. After passing electricity, you can observe that copper wire again. Is there any movement of copper ions, copper metal atoms? Are any change in the position or composition of that copper metal even after passing the current? If you observe the same copper wire even after 1 year, 10 years, 20 years, what happened? There is no change in its composition, because when copper wire is allowed to pass the electricity, only electrons are moving rather than ions, rather than copper atoms. That's the reason why positive ions never participate in the movement in the transportation of current. Only electrons are passing from one region to another region. That is in the case of metallic conduction, and that is absolutely reversed when we are taking the conduction in case of ions, where sodium chloride was taken into a container and we are inserting 2 electrodes, and through that electrodes, if we are passing the current, what happens here? Opposite ions are moving towards the different electrodes, so that because of that diffusion, that kind of directional flow of ions, what happens? They are used to generate the potential, and there is the origination of current is possible. That is the second case. In case of liquid or solution forms, because of movement of ions, the conduction is possible. In case of metallic materials, where only flow of electrons are possible rather than all the kind of positively charged species will be stagnant only. That will be the distinguished kind of movement of ions. In case of only electrolytic solution, you may say ionic solution, and in case of metals, only electrons are allowed to flow. This is a kind of representation. Do positive charges will move in the conductor? Yes, it is possible, but only under certain circumstances, where it will be only when ionic conductance is ionic conductor was taken. In that case, positive charges are also allowed to move. But when we are taking metallic conductor, only electrons are allowed to flow, but not copper ions. They will not migrate from one place to another. So this is a kind of situation, depends upon the type of conducting material we are choosing. And we are going to recollect our previous topics, which already completed in the previous sessions. Recollection. Let us recall your previous experience of electrolysis and electroplating process and conductivity of fluids that you had already learned in the earlier classes. Let us go one by one. What is meant by electrolysis? Electrolysis is nothing but electro means by using current. Lysis means breaking of bonds. Lysis. Hydrolysis means by using water. If you are breaking bonds, that is called hydrolysis. Electrolysis means by using electrical current. If you are going to break the bonds and making into ions, that is called electrolysis. If you are taking sodium chloride added to water, sodium positive and chloride negative ions will be ionized, and they get migrated towards opposite electrodes in the presence of external electric field. That is the simplest example for electrolysis process. Here is the electrolysis of copper sulfate was taken. Copper sulfate, when added to water, copper becoming into copper dipositive and sulfate into SO4 -2. So they are migrating towards opposite electrodes, and they get deposited on their respective electrodes, so that here potential difference is generated, and that used to originate the electrical current. So this is a kind of situation where electrolysis process got carried, ionization of ions and migration towards respective electrodes. And what is meant by electroplating? Electroplating is nothing but any object what you want to protect, that will be taken as a cathodic region, and another which you want to add as a surfactant, just like a painting of wall. Here also we are going to paint this object with our selected metal. So metal, it is not possible to coat one metal and another. That's the reason why we are applying this electrical current. In the presence of electrical current, one metal is going to be diffused on the surface of another object what we are going to protect. For example, if you are taking iron, otherwise here benefits iron was taken, and gold is used to protect on the surface. So gold is taken as an anodic region. By applying electrical current, gold used to diffused on the surface of this iron, so that it will be completely protected. In this manner, electroplating is nothing but coating of one metal on the surface of another metal in the presence of electrical current is called electroplating. So here copper plating and gold plating, all these are the simplest examples in order to get this kind of protection. Now, any other kind of system where we can say conductivity of fluids. Just now we discussed some of the ions are able to pass the current from one region to another, so that conduction and so that potential difference origination is possible. All the galvanic cells are the simplest examples of that kind. Electrolytes were taken and they are used to migrate in order to seek the electrons, in order to lose the electrons. In that case, fluids are able to move from one region to another region, so that conduction of current is possible, right? High quality deionized water having conductance around 5.5 microsiemens per centimeter. Drinking water having 50, because some of the minerals will be there, so that here conductivity of water mainly depends upon the dissolved minerals in that. When we are taking high quality deionized water, means ions are completely removed. In that case, negligible quantity of conduction will be there. Where ions, because the water is almost considered as a non-conductor in the pure state, because ionization into H plus OH minus is almost negligible. That's the reason why the quality of conductance of water mainly depends upon the additive minerals in that. When you are going with a high quality deionized water where the conductance is extremely low, so here micro cements were taken here. In case of drinking water, it will be extremely large because the drinking water added with some requisite minerals so that they are used to conduct the current. This is called the conductivity by fluids. Fluids are nothing but liquids. In the liquid state, conduction is possible through the ions. This is called ionic conductance. When we are taking a simplest familiar example called a salt solution and a sea water was taken, where fluid conductivity is extremely large because the salt content will be extremely large when we are taking a sea water, where minerals are extremely large and ions mobilize, certainly they used to pass current in the larger extent. Some fluids have even higher conductivities because of high level of dissolved solids. So here solubility, number of ions and the speed of ions are the main criteria in order to measure the conductivity of various fluids. All these topics were completed, and what is meant by electrolysis, what is meant by electroplating, and what is the process of conductivity by the fluids. All these were already discussed, completed in your previous sessions. So just it is a recollection. Now, we are going to move on with how the potential difference is going to be generated. When electrical current is allowed to pass through the fluids, the positive ions and negative ions move in opposite directions. So that is obvious case. Positive ions will move towards the electrode where high electron density is there. Negative ions are moving towards the electrode where low electron density is there. In that way, they are moving in the opposite direction and they get deposited on their respective electrodes. When you are taking the simplest galvanic cell as an example, cathode denoted with positive, anode denoted with negative, because high electron density will be assigned for the anodic region, so that here cations will be migrated toward this anodic region. Whereas positive means low electron density, negatively charged ions will migrate towards this cathodic region. This is a kind of representation. Both ions of opposite charges are moving in the opposite direction in order to get the electrical neutrality. Now, a direction of motion of positive charges in the electrolyte always in the direction of electrical field, while negative charges move in the opposite to the positive charge. Obviously, charge density is more with the ion and charge density is more with the electrode, the repulsive forces will operate it. In order to minimize all these conditions, positively charged ion will migrate towards high electron density. Negatively charged ions will be migrated with the low electron density, so that electrical neutrality will be maintained. That is the main criteria for this origination of potential difference. Now, thus for the conductor in the fluids, there exists a motion on the both opposite positive and negative charges. So when we are taking the electrolytic conductor, that means ionic conductor, that means the salt added to water. In that case, positive and negative ions are having tendency to move in the opposite direction. Whereas in case of metallic conductor, only the possibility will be motion of electrons, but not the remaining ions. Metal ions will not participate in such a migration. The free electrons, how they are present, how they are floating on the surface of metal. Just like when we are taking any lightweight material and added to water, they are floating on the surface of water in the similar manner. Electrons are floating on the surface, being these are light in weight, they are floating on the surface of metal and they are having tendency to move from one region to another in the spontaneous manner. This is a kind of metallic conduction. And potential difference, how it will be originated, why we are taking two different directions here, what is meant by contradiction between these two statements. Let us discuss in detail. If positive charges move from the point A to B, for example, I'm taking sodium positive, and that allowed to move from point A to B in a conducting material, right? The electric field does a positive work. So work done by the electric field is denoted by W by Q. W means the work done, Q is the unit charge, where we are operating this electric field is positive. When W by Q will be positive, positive charges are moving from point A to B in the conductor. what happens? During this moment, electric field used to done the positive work, that is denoted by the W by Q. So if W by Q is denoted, that will be positive, assigned with the positive notation. These are for free positive charges. You can see that direction of electrical field from A to B in the point A is a higher potential and the B is the lower potential. This is the case required. This is the important condition required in order to get this positive, because always the natural tendency of power or potential is from higher to lower in order to get the equilibrium. Then only here positive notation will be assigned for W by Q. This is a kind of situation for the natural tendency. Now we have another contradiction. As the negative charges always move in the direction opposite with respect to the electric field, we consider electrons move from low potential to high potential. So when we are taking negative charges, in that negative charges are there, already negative charges there with us. That's why it having tendency to move towards low electron density. This is the opposite direction. Positive charges are moving in, for example, right hand direction, whereas negative charges are moving in the left hand direction in order to get the electrical neutrality. The final intention of both the charges in order to get the equalization of all the charges, right? Here is the opposite direction is assigned for these negative charges. Now, move on to, we know that a battery or a cell constant potential difference is maintained till the battery is completely discharged. Potential difference is always maintained with the equilibrium and the given cell notation reaction. So this will be operated spontaneously until the battery get discharged completely. Till the complete discharge, and the work will be continued, and there is a maintenance of electrical neutrality between the positive and negative charges which are moving the opposite direction, and the potential difference get constant. And we have one question. How does a battery maintain the constant potential difference between its terminals? So for example, if you are taking a battery, we are discharging continuously. After some time, what it will happen, while continuous discharging, it should lose energy, and it should completely completely becomes a not working condition. But this doesn't happens until the complete discharge of battery is possible. How can we maintain that potential difference in the equilibrium in between the two terminals of that battery? So this is the question. I collected this answer from the platform called Brainly. Thank you very much for your valuable information here. The voltage between the battery terminals are first defined by the chemical reactions inside the battery. How the constant potential difference gained by the battery? Because there is a continuous process of chemical reaction inside the battery, so that electrons are released by the more susceptible metal having tendency to lose the electrons, and another having tendency to seek the electron. That kind of repetition of chemical reactions are possible in the series of steps, so that this expensive chemical reaction used to generate the potential difference that used to maintain in the constant manner. So here battery is working without any fluctuations and maintaining constant potential difference between anode and cathodic region because of this chemical reaction which occurred inside of the battery. Then current flows during the charge operation. The terminal voltage changes due to the internal resistance. Here, conduction is nothing but flow of current or ability to move the electrons from one region to another. Whereas in the opposite manner, resistance is also there. Every material having certain extent of resistance. Some may have higher extent, some other may have less extent of resistance. Resistance is nothing but stopping them to move the electrons from one region to another. That doesn't allow the passage. That will restrict the passage of current. That is called the internal resistance. That is also operated, but when we are taking metal, this internal resistance will be negligible. When we are taking insulator, internal resistance will be dominated, and the resistance will be more, conduction will be less in that case. So that here, the main cause for the constant potential difference is the operation of the chemical reactions inside the battery. And one more explanation is also there. through the chemical energy inside, which it generates through the chemical reaction. Here, because of chemical reactions, the potential generated, that is denoted as the chemical energy. Because of this chemical energy, here constant potential difference maintained in between anode and cathodic region. This is the simplest example for a galvanic cell, which is also known as electrochemical cell, where anode and cathode were made and electrical circuit was created so that the current passage is possible and illumination of bulb is done here. This is the kind of system where chemical energy get converted into electrical energy. Another question is posed for you. Why does a battery discharge when its positive and negative terminals are connected through a conductor? Battery discharge when its positive terminal and negative terminals are connected to the conductor. So we are operating the battery after certain hours. For example, we are taking mobile battery. That will be operated for a day or 2 days if no other obstacles are there for 3 days max. So in that case, why after certain hours, why the battery got discharged? So I collected this answer from Doubtlet. Thank you very much for your valuable information. A conductor permits the charges to pass it due to its exertion of charges. Exertion of charges is created after the completion of the charges. So when battery is connected with the conductor, it gets discharged because at the expense of chemical reaction, the energy generation is possible spontaneously when it is connected with the conducting material through its terminals that used to supply the current through the conductor. When the supply of current is possible, at that instance, a battery is slowly giving away the energy to the conductor so that it get discharged. After some time, its energy will be lowered. And we have a detailed description about a battery. To answer this, we need to know about how battery or cell will work. A battery is the source of electrical power. Instantaneous energy production is possible by this battery. Nowadays, it became essential material at the whole household purpose, industrial purpose, automobiles. Everywhere we are using these batteries as a key materials for the source of energy. And they consisting either one or more electrochemical cells which are connected in a series and powering electrical devices. So many kind of electrical devices are powered by these batteries like flashlights, mobile phones, electrical cars, and even electronic gadgets are powered by these batteries. And the main principle which accomplished in this battery will be chemical energy converted into electrical energy. To answer this, we need to detailed description about the batteries provided to you. A battery consists of two metal plates. Two metal plates are arranged inside, and these are denoted as electrodes. And chemical is poured into this one. The liquid material which surrounding these two electrodes are called the electrolytic solution, where ionization of materials are possible. Electrolyte between the two metal plates are consisting positive and negative ions. For example, if you are taking copper sulfate solution, copper dye positive, sulfate dye negative charges will be there. So that is acquiring both the charges with the positive and the negative ions inside this cell. And they having tendency to move towards the opposite direction. Always SO4 minus 2 ions tends to migrate towards a positively charged electrode, and copper plus 2, Cu plus 2 ions having tendency to move towards a negatively charged electrode in order to make the electrical neutrality. In this manner, always there is a kind of system which originated in this manner. Establishment of cell is possible by taking two metals called electrodes, dipped into the solution called electrolyte, where positive negative ions will be there. And these two metals having positive negative charges, always opposite charges having tendency to migrate. So this is a kind of representation. Now, electrolyte exerts a certain force on these ions and makes them to move in the specified direction. Let us call this force as a chemical force. Here, the definition for the chemical force is given. This chemical force exerted by the electrolytic solution. That electrolytic solution will drive the ions to move in the specified direction. For example, that electrolyte having tendency to localize those ions towards the cathodic terminal. So that force which operating to move ions towards to reach that cathode is called a chemical force that will be operated to reach that electrode. So that is exerted by the electrolytic solution, which is denoted as a chemical force mentioned with the FC, chemical force. Now, depending on the nature of chemical, positive ions move towards one of the plate and accumulated in the plate. As a result of this, accumulation of charges in the plate becomes positively charged, called anode. So here, chemical force used to give the direction to move the ions, so that ions are going towards one of the electrode and get deposited on that. Because of that deposition, if we are taking positively charged ions, they will obviously moving towards the negatively charged electrode and they will accumulate it on its surface, and that accumulation purely because of the chemical force which operated by the electrolytic solution. Now, negative ions move in the direction opposite with respect to the positive ions. They are moving towards negative ions, low electron density is required for them. That's the reason why these negative ions are moving towards a low electron density and they get deposited on those ions, and this is denoted as a cathodic radiation. Now, any other new term introduced here? Till now we discussed about chemical force and another called electrical force. This accumulated different charges in the respective plates continues till both the plates are sufficiently charged. Positive charges are moving towards cathode and negative charges are moving towards anode in this manner, or they are accumulating continuously, right? But the ions in the motion experience any other force. Sufficient number of charges accumulated on the plates. Let us call this force as electrical charge. After the deposition of these ions on the surface of metal rods, some extent of force exerted by that metal rod, that is called the electrical force. The force which operated by the electrolyte in order to give the direction to flow for the ions, that is called a chemical force. After the deposition of all these ions on the metallic surface, that metal exerts an extent of force, that is called electrical force. That is denoted with Fe. Right? The direction of the force opposite to the direction of chemical force. Always chemical force, for example, operated in right hand side direction. This electrical force is operating in the left hand side direction. Both are reciprocal to each other. If chemical force is operating in this direction, for example, electrical force is operating in opposite direction, right? So this is a kind of system which simply represented in this equation form. Both are reciprocal to each other during their operation. Now, the motion of ions continue towards the respective plates of if the chemical force is greater than the electrical force. If chemical force is greater, then only ions having tendency to move and they get deposited on the surface of electrode, then only it is possible to deposit. The condition required is chemical force should be greater than electrical force, then only movement of ions are possible. If electric force is greater, what happens? Electricity flow is possible rather than ionic flow. So that's the reason why in order to flow the ions, chemical forces should be dominated. Now, after the complete accumulation of ions on the surface of metal, what happens? At particular instance, both the forces get equalized. This is called the equilibrium state, where chemical forces exactly is equal to electrical forces. At that instance, movement of ions are not possible, movement of electricity is also not possible. That is called a stagnant state, where both are getting equalized. Now, at this situation, there will not be any motion, because both are exactly having equal energy, need not to move ions, need not to move electricity. So motion of current, motion of ions are not at all possible, being Fe and Fc both are exactly equals. That is represented in the figure number 8, where both the charges are not moving anywhere, they are stagnant in nature. A new battery that buy from the shop at the stage where the ions electrolytes are under the influence of balanced forces. When we are purchasing a new battery, at that instance, we are not started operating that one, and we are not started giving external energy to that one. At that instant, that is at the equilibrium. So where chemical energy operated exactly is equal to electrical energy operated. So that is the case where new battery purchased from the shop. Now, in either case is going to be discussed in the reason. This is a reason for the constant potential difference between the terminals of the battery. When two terminals of battery were connected, so that here potential difference will be stabilized, and at that instance constant potential difference will be generated. Constant potential difference will be generated at that instance. Now the important parameter will be the amount of charge accumulated. How much amount of charge accumulated either in the cathode or the anode. That purely depends upon the nature of chemicals we are applying as an electrolytic solution, as an electrode solution, electrode material. So this is an important criteria. Here, amount of charge accumulated mainly depends upon the nature of the chemicals we are operating in the battery. This is the important condition to be remembered. And it is the question time. We are going to pose a question for you. What happens when the battery is connected with the circuit? When the battery is connected to the circuit, electrons produced by the chemical reaction at the anode flow through the circuit towards the cathode. At the cathode, the electrons are consumed, and in either chemical reaction, the voltage difference is generated, so that the generated potential difference is defined as an electromotive force. This is simply denoted as EMF. What happens when the battery is connected to the circuit? What happens in that circuit? Anode used to release the electrons, cathode used to seek the electrons, and that will flow through the circuit, and because of that reason potential difference is created. Potential difference is the origin for electromotive force. Because of this one, illumination of bulb is possible here. What happens when the battery is connected to the circuit? In continuation to the previous one, when conducting wire is connected to the terminals of battery, potential difference is created between the two ends of conductor. So two ends of conductor is experiencing one in high electron density and either in low electron density will be there. This is mentioned in terms of potential difference. That sits in the electrical field throughout the conducting material. Direction of electrical field from the positive terminal to negative terminal in the conductor. Always high density to low density current flow, electron flow is possible. We know that conductor contains a large number of electrons. Always conductor having a large number of electrons. When we take copper being it is associated with the D9 4s1 electron system, and 4s2 D9 electron system. By losing one electron, it will become completely filled electronic configuration. That's the reason why strong tendency to lose electron being it is electropositive in nature. Right, always, not only copper, all the materials are having that type of tendency to lose the electrons, and the larger extent of valency, freely, loosely bounded electrons are associated with the metallic conductor. The electrons near the positive terminal of the battery attracted by the and started to move towards the positive terminal. When this conductor is associated with the positive terminal, what happens? This conductor having high electron density and a positive terminal having low electron density, so that the association will be more, and movement of electrons are possible spontaneously in this manner. Electrons are moving from high density to low density in this direction. Now, as a result, amount of positive charges in the plate get decreased, so that electrical force becomes a weaker. Electric force when becomes a weaker, chemical forces will be stronger, so that ions are moving. Movement of ions are possible, right? And chemical forces pull the negative charges and the positive charges from the positive plate and makes them to move towards the negative plate. This chemical force is the driving force which is originated from the electrolytic solution. This positive charge is moving towards anode, negative charge is moving towards cathode. When the condition will be chemical forces are greater than electrical forces, in this condition, it will drive the opposite charges, positive towards anode, negative towards cathode in this manner. Now, The negative terminal pushes one electron into the conductor because of stronger repulsions between the negative terminal and the negative ion. When negative terminal with the electrons are there, what happens? Both are closure intimacy. There is a operation of repulsive forces because negative charge with a negative high electron density will not be preferable always. Hence, total number of electrons in the conductor remains constant during the flow of current. Total number of electrons remains constant because how the conductor releasing electrons in the same extent it is seeking electrons from the battery or the energy source. That's the reason why after switching off entire copper wire, the net electron count remains the same, that neither loses nor gains. Conductor just to pass the current from one place to another place. How rocket is used to take the satellite from the earth to the space. Rocket is only the vehicle used to transport. In the similar manner, conductor is used to transport the electrons rather than giving or seeking electrons. Okay, so it used to transport from one place to any other place. Above said process continues till the equilibrium is attained between the forces of electricity and forces of chemical energy. So same pattern will be continued until they are attaining the equilibrium condition. What is the equilibrium? Chemical energy forces, electrical energy forces, both are at the equal instance. Till that case, the process of continuous flow of electrons are possible. If once equilibrium is maintained, flow of electrons gets stopped, movement of electrons not possible, current origination is also not possible. By this, we completed this session. Hope this will helpful for your preparation. Thank you very much for your consistent listening. Thank you one and all.